right, here we go. Question 22 from our Precalculus homework number 12 in MyLab Math. They want us to write the partial fraction decomposition of the given rational expression. And looking at this rational expression, we can see that the factors are linear and that there is a repeated linear factor. The fact that x minus 4 is squared means if I were to write that out, there would be two of those multiplied. So this is going to be the second case for our partial fraction decomposition. Let's go to the scratch work and see how to work this one out. So the way that we're going to deal with the repeated linear factor, first I'm going to take the linear factor that is not repeated, and we're going to set up a fraction a over x plus 2 plus. And then what you need to know is that every power of the repeated linear factor has to be represented in its own fraction. So we're going to have another fraction with probably a different numerator with x minus 4 to the first. That accounts for that repeated linear factor to the first power. And then we're going to have another fraction for the next power of the repeated linear factor, which is x minus 4 squared. And so in this case, notice I don't really need to write the x minus 4 to the 1, it's just x minus 4. We are going to have three variables we need to solve for. And so the next step is going to be to get rid of the fractions and then solve for a, b, and c. Now the way we're going to do that is we need to multiply the left-hand side and the right-hand side by the LCD, the lowest common denominator, which is this given denominator. So if I multiply the left-hand side by the LCD, those are going to cancel and leave me only x squared. On the other side, if I multiply by x minus 4 squared times x plus 2, I'm going to have to distribute that to all three numerators. And in the first fraction, the x plus 2's are going to cancel. Here, let me show that. The x plus 2 cancels, leaving me a times x minus 4 squared. And then we're going to do the next fraction. So next we're going to have plus b times, here the x minus 4 will cancel one of the factors of x minus 4, but leaving a factor of x minus 4, and also the x plus 2 is still there. And then for the third fraction, we're going to have plus c times, and in this case, the x minus 4 squareds cancel, leaving only the x plus 2 to multiply by c. And that effectively eliminates the fractions. Now we need to eliminate all the parentheses and combine like terms. Okay, so what I've done here is I've taken the equation that we arrived at and I've separated my x minus 4 squared into separate factors. And I don't know if you can see this, but we are going to have to FOIL twice and distribute here once. So this is going to take a little bit of work to get to the next step. All right, here we go. A times, and then doing the FOIL method, x squared minus 4x minus 4x plus 16, and then plus b times, doing the FOIL again, x squared plus 2x minus 4x minus 8 plus, and I'm going to go ahead and distribute the c. That's going to give me cx plus 2c. And then the next step would be to distribute the a and the b and then combine our like terms. All right, here we go. Ax squared. Notice I'm going to have a negative 4ax and another negative 4ax, so I'm going to combine like terms as I go, making a negative 8ax, and then a times 16 is just a16, or I could say 16a. I feel better about that. Let's write that as 16a. plus. And then with the b times x squared, that's a bx squared. I'm going to have a 2bx and a minus 4bx. Negative 4 plus 2 is negative 2bx. Do you see what I did there? I combined like terms on the fly. Minus 8b plus cx plus 2c. Now at this point I can see that I have two x squared terms, and so what I want to do is combine those by factoring out the x squared, and that will leave me a plus b times x squared. That takes care of the squared terms. Next, I have a minus 8ax, a minus 2bx, and a plus cx. All three of those terms have an x. And so what I want to do is factor out the x, and that will leave me minus 8a minus 2b plus c. Do you see that? Minus 8a minus 2b plus c. All of those are left in the parentheses if I take out the x. And then the last thing, the constants. I have a plus 16a minus 8b plus 2c. So let's say plus 16a minus 8b plus 2c. All of that would represent the constant. So this is the coefficient of x squared. This is the coefficient of x. This is the constant. And now for the left-hand side to equal the right-hand side, the coefficients of the variables have to match. So we can see the coefficient of x squared is 1 on the left, so we know that the a plus b would have to be 1. The coefficient of the x squared on the right would have to equal the coefficient of the x squared on the left. Now on the left-hand side, there is no x and there is no constant. So that's going to give me minus 8a minus 2b plus c. The coefficient of x would be 0 since there is no x over here. Likewise, the constant would also be 0 because there is no constant on the left. So 16a minus 8b plus 2c, that would also have to be 0. And now I have a system of 3 equations with 3 unknowns, and I have a couple of techniques I can use to solve that. So we can solve by the elimination method. We can solve using Gaussian elimination with row operations. We could also solve this using Cramer's rule, but the way I'm probably going to solve this is with my Casio. So whether you know it or not, the Casio ClassWiz has a system solver. And the way we get there is we go to Menu. We're going to go down twice and over once to the equation/function app. Hit equals to select. And this is a system of linear equations, which is the same as simultaneous equations. The number of unknowns is the number of variables, which is 3. And then I simply need to input the coefficients of a, b, and c. And you need to notice that x, y, and z will represent a, b, and c. So now, inputting the coefficients for the first equation, we have 1a, 1b, no c. So I'm putting a 0 for c equals to 1. And then you rinse and repeat for the second equation. Negative 8 equals negative 2 equals. The coefficient of c next is 1, and the constant is 0. And last equation, 16, negative 8, 2, and 0. Now if you hit equals one more time, it's going to give us the solution for x. Remember, this is the solution for a. A is a 9th. B is y, 8/9, and Z is 8/3. And now we need to take this back to our MyLab math and see if we're right. All right, so I'm back at the MyLab math. I have entered the value for A. Remember, A was over the x plus 2. I've entered the value for B, which was 8/9 over the x minus 4. And then the value for C over the x minus 4 squared. And that, even though it's really effed up, that is the correct answer. So that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.